When we think of viruses, we often think about the conditions they cause, such as COVID-19. But viruses can be useful tools. We can inactivate them and have them transfer genetic information inside of the human body. This is exactly what lentiviral vectors do. At GetGenix, we produce these lentiviruses at large scale. The way we do this is by going through a series of steps, but today we'll be focusing on the size exclusion chromatography unit, or the SEC column. The SEC column takes in a feed of proteins, DNA, and lentiviral vectors, or LVs, as well as buffer. The impurities, proteins, and DNA are much smaller in comparison to the LVs. As a result, they are able to enter the resin or the stationary phase of the column. The LVs, however, remain in the mobile phase at all times, and as a result, exit the column much more quickly. This can be represented by the first peak on the graph. In comparison, the impurities take much longer to exit the column and are therefore represented by the second peak. The SEC unit can be modeled based on the governing mass balance equations that result in a system of partial differential equations. This system allows us to model the concentration of the impurities with respect to position and time. Specifically, it looks at the concentration within the mobile phase as well as the concentration within the stationary phase. Using the governing equations, a MATLAB model was developed. In addition to the equations, the model took in information particular to the column, including its length and diameter, the resin, such as the particle size, the buffer, including its viscosity and density, as well as parameters pertaining to the impurities of DNA and protein. From there, the MATLAB model was able to discretize the column into a series of 100 slices using the method of lines. It also accounted for 250 time steps. The model was able to take a system of two partial differential equations and convert it into a system of 50,000 ordinary differential equations, which it then solved. Solving the MATLAB model resulted in concentration profiles such as the one shown here. From these concentration profiles, I was able to read off the maximum purity levels that were achieved. And using this model, I was able to design a column with these specifications so that a purity level of 98.71% could be achieved. I was able to validate the MATLAB model using commercial software, which resulted in purity levels of around 85%, leading to a 15% margin of error. I was also able to validate using literature values. Thank you.